Hello friends, welcome back to my classroom. In this class, I'll try to explain how to calculate higher transition probabilities in a Markov chain. In a Markov chain, the probability of moving from one state to another in one step is called the one-step transition probability. And these probabilities are represented using a transition matrix. For the detailed explanation about how to write the transition matrix, you can check my previous video. I have given the link in the description box. But just to start this video, let me take a simple example of a transition matrix. Suppose I have the study habits like this. I may study on a day or I may not study on some days. Okay. And if my habit is like this. If I study today, the probability that tomorrow also I study may be 0.4. Okay. So what does it mean? The probability that I will not study tomorrow is going to be 0.6. Alright. And if I don't study today, maybe the probability that tomorrow I'll study is 0.7. In that case, not studying today and tomorrow also not studying, the probability may be 0.3. So this is one step because I am talking about what happened today and what might happen tomorrow. Now, what if I want to calculate the probabilities, let's say after 10 days. Suppose today I have studied. What is the probability that after 10 days, exactly after 10 days, I study? Okay. So in this case, these probabilities of the probabilities of the states after 2 or more days, okay, or 2 or more steps, they are called as higher transition probabilities. Okay, or after 10 days means it is called 10-step transition probability. After 12 days means it's called 12-step transition probability. Okay. So now to calculate these higher transition probabilities, we need to know matrix multiplication. All right. Before that, let me tell you what Pij of n denotes. All right. Suppose P is the transition matrix. All right. Pij of n, okay, denotes the probability of going from state I to state j in n steps. All right. Say for example, I have two states. Like I said, A1 might be the probability of the state of study, and A2 is the state not study, and A1 and A2 here. Suppose P is this, right? So after 10 days, if I have studied today, that means I is 1, that is the first state, and I want to know what is the probability that I don't study. I don't means it is 2 after 10 days. So P12 of 10. How to get P of 10? You just need to multiply P 10 times. Alright. So this is matrix multiplication. P into P into P into P into P. Alright. If you multiply 10 times, you will get P of 10. In that, the position 1 to 2. Suppose this is P10 is, again I'll take the same matrix. Suppose this is P10, then P12. 1 is the first row and second column. This probability will give you the value, okay, that the probability of the state going from study to not study after 10 days. Alright. So let me consider one example, quick example, how to calculate the probabilities in a real life situation. So I have this example. Each year Arjun trades his car for a new car. This is his habit. Okay. Suppose he owns a Nissan car this year. He trades it for a Honda next year. Okay. And if he owns a Honda this year, then he trades it for Toyota next year. And if he has Toyota, then he is equally likely to trade it for a Nissan, a Honda, or a Toyota. Alright, this is the situation, and for his trading habit, okay, I need to write the transition matrix first. Okay, so let me try to write the transition matrix P. P, he has I mean, states are three here. One is Nissan, he might have Nissan on some years, he might have Honda, or he might have Toyota. So I'll take state 1 as Nissan, state 2 as Honda, and state 3 as Toyota. Okay, so next year what's going to happen? Nissan, Honda, Toyota. Since three states are there, it's a 3 cross 3 matrix. Alright, so let us understand. First one, if he owns a Nissan this year, he trades it for a Honda. He will not go for Nissan again. He will not go for Toyota. He will just buy Honda. So 100% chance that if he has Nissan this year, then he will have Honda next year. So that probability is 1. So Nissan to Nissan is 0. Nissan to Toyota is also 0. Right? And what if he owns a Honda? So I'll take it in the second row. If he has a Honda now, he trades it for a Toyota. So for sure, he will buy Toyota only. So this is full probability 1. If he has Honda, first second row, then he will go for third column, Toyota. Alright, 0 to, 1 is the probability that if he has Honda now, next year he will have Toyota. Alright, so he will not have no Nissan, he will not have Honda. Alright, now let us take the third one. If he owns a Toyota, he is equally likely to trade it for a Nissan, a Honda, or a Toyota. What does it mean? So now this year he has Toyota. Next year he might have Nissan, he might have Honda, or he might have a new Toyota again. So with equal probability. So all the three, and sum should be equal to 1. So it's 1 by 3, 1 by 3, and 1 by 3. Okay, all have equal chance. Alright. Okay, this is the transition matrix. Now I'll try to calculate the higher transition probabilities. What probability? In 2026 he has a Toyota. Okay, so this year suppose he has a Toyota. What is the probability that in 2028 he will have a Nissan? Or what is the probability that in 2028 he will have a Toyota? Or what is the probability that in 2028 he will have a Honda? Which will have the more chance? Okay, that we need to calculate. Alright, so 2026 to 2028. Alright, so initial year is 2026, and we need to calculate what will happen in the year 2028. So it is a two-step transition. Alright, 2026 to 27 is one step, and 28 is two steps. Okay, so two steps. Whenever you need two-step probability, you need to calculate p power 2. Alright, how do you calculate p power 2? It is p multiplied by p. Matrix multiplication. P is available here. Transition matrix. If you find p into p, you will get p square. Alright, so once again I am telling, if you do not know how to multiply two matrices, check for one of my earlier videos. Alright, I have given the link in the description box. Alright, okay, let's see what is p square. Alright, if this matrix p is multiplied p into p, what are we going to get? So this is p. First row is Nissan, second row is Honda, third row is Toyota. Similarly, for the next year, first row is Nissan, first column is Nissan, second column is Honda, and third column is Toyota. Alright, now p into p square is p multiplied by p. So I'll multiply two matrices, 0, 1, 0, 0, 0, 1, 1 by 3, 1 by 3, 1 by 3, multiplied by same matrix, 0, 1, 0, 0, 0, 1, 1 by 3, 1 by 3, and 1 by 3. Right? So if you multiply these two matrices, your result is going to be this. Okay? So 0, 0, first one is 0, and second 0, 0, 1, 1 by 3, 1 by 3, 1 by 3, and 1 by 9, 1 by 4 by 9, 4 by 9. So these are the transition probabilities after 2 steps, after 2 years. Now we would want to know what is going to be the probability that in 2028 you will have Nissan, you will have Honda, or you will have Toyota. Okay. So in 2026 what he had is I guess it is, yeah, in 2026 he has a Toyota. Okay, that is third state. First state is Nissan, second state is Honda, and third state is Toyota. So initial vector is 0, 0, 1. Okay. Suppose he had Honda in 2026, this would have been 1, 0, 1, 0. Since he has Toyota, Toyota is the third state. In third state, third position, you will have 1. Okay. In other positions, you have zeros. So once this initial vector is multiplied to p square, you are going to get, since it is the third position is 1, you will have third row in the result. What I am asking you to do is you multiply initial vector to p square. Okay, once you have multiplied this, your result is going to be 1 by 9, 4 by 9, and 4 by 9. Right? So now you have the result. In 2028 you will have the probability that you will have Nissan is 1 by 9, the probability that you will have Honda is 4 by 9, and the probability that you will have Toyota is also 4 by 9. Nissan is having very less chance. Alright, you have Toyota now, so again having Toyota you have 4 by 9, again having Honda you have 4 by 9 probability, but again having Nissan is little less. Alright, only 1 by 9 is the probability. Okay. Similarly, you can answer any question, okay, after any number of years. You just need to see how many steps are there. Okay. So in the same example, I have taken one more requirement. In 2030, what's going to happen? 2030 is 4 years from now, 2026. So we would need p power 4. Okay. So p square into p square, if you multiply, you will get p power 4. Alright. If you want 2029, year 2029, you would need p cube. That can be obtained by multiplying p square and p. Right. Now since you want 4 years from initial, okay, 4 years from initial means you have 2030 is 4 years from 2026. Okay. So 4 years means you would need p power 4. So to get p power 4, you just multiply p square into p square. Okay, and the result is going to be this matrix. Again, if you have, since you have Toyota, you just see the third row. Okay, so 16 by 89 is the probability that you will have Nissan in 2030. 28 by 81 is the probability that you will have Honda in 2030, and 37 by 81 is the probability that you will have Toyota in 2030. Okay, it depends on initially what you have. Suppose you had initially, if you had Honda, your initial vector would have been 0, 1, 0. That means you have to see second row. Second row will give you your result. In 2030, 4 by 27 is the probability that you will have Nissan. 7 by 27 that you will have Honda. 16 by 27 that you will have Toyota. Alright. Hope you have understood how to calculate higher transition probabilities. Alright. Okay. And to conclude, this higher transition probabilities help us understand how a Markov chain evolves over time. Okay. By using just a simple matrix multiplication, we can easily compute the probability of transitioning between states over multiple steps. Okay, making it a powerful tool in stochastic modeling. Right? Thank you. And in our next class, we will discuss fixed probability vector. What is a fixed probability vector and steady state Markov chain.